Hello everyone, welcome back. This is Engineer Hussein Mosapi. So in this video, we'll be looking at differential equations and the aspect of learning how to apply the separation of variables. So a question might be phrased where you'll be asked to solve a differential equation and you need to know if you can apply the separation of variables. Alright, so before we begin, do not forget to like and subscribe to the channel. Alright, so now how can you understand that what you're trying to find involves the separation of variables? Now say you have a differential coefficient dy over dx. And let's say this is equivalent to two functions, the function of x and the function of y. In the other videos that I've made, I have explained how you can use direct integration. For direct integration, that's the case where we now just have one function on one side of the equation. In this aspect, we're having the function of x and the function of y. Therefore, we can separate x and y and then solve them separately. So, how do you go about doing this? So, we're going to make sure that the x's are on one side and the y's are on the other. So, since dy over dx is equal to f of x times g of y, we can multiply everything by dx. Then we'll have dy being equal to f of x times g of y times dx. Then after that, I'll take the other y on the other side by multiplying the entire equation by 1 over g of y, or rather just dividing. So you have 1 over g of y dy being equal to f of x dx. If you apply integration on both ends, you will get your differential coefficient upon applying star. Be mindful that every time you're solving differential equations, the goal is to find y being equal to something. That is basically the goal. Now, let me help you understand this with examples. Alright, say we have a question that says solve. Let's make it an initial value problem. Solve the initial value problem. Y prime being equal to x cubed e to the minus y. And then y at 1 is 0. Let's solve this. Now, remember, y prime is a differential coefficient because y prime is the same as f prime of x. And then this is the same as dy over dx. Therefore, one can imply that y prime is dy over dx. So we have dy over dx being equal to x to the third times e to the minus y. So what we can do is apply the separation of variables. The steps are quite basic. Step 1, separate the variables. By separating the variables, it simply means we're placing the variables separately on one side, putting the x's on one side and the y's on the other. So by doing so, what I'll do is I'll just cross multiply this and say dy is equal to x cubed times e to the minus y times dx. Then I can divide everything by e to the minus y, which is basically like multiplying by 1 over e to the minus y. And I have e to the minus y there. This will cancel with that. And you have dy, say 1 over e to the minus y, dy being equivalent to x cubed dx. Now this might look a bit shocking, but if I collect data, now look here, we're having 1 over e to the minus y. Remember, whenever you have a to the minus b, this is the same as 1 over a to the b. So in a similar manner, this is the same as 1 over 1 over e to the positive y. And then this simply means that I'm having 1 divided by 1 over e to the y. And then this is the same as 1 over 1 times e to the y over 1, which basically just gives us e to the y. So we have e to the y dy being equal to x cubed dx. At this point star, we have separated the variables. Now, once we separate the variables, the next step is supposed to do is to integrate both sides. Applying or introducing the integral sign, dy, integral of x cubed dx. Now, once we do that, it implies that if I apply integration on one side, what am I going to get? Now, what is the derivative of e to the something? And what is the integral of e to the something? Remember, when it comes to derivatives, let me just erase this. When it comes to derivatives, remember, if you have d over dx of e to the something, that is if you are looking for the derivative of this is always the derivative, let me say d of something, then multiplied by e to the something. With integration, it's quite similar. Rather, we do not multiply but divide. So if we're integrating e to the minus, the integral of e to the y dy theta is equal to e to the something, which is y, divided by the derivative of something. The derivative of y, if we're integrating with respect to y, will just be 1. So we just have e to the y. So we end up having e to the y being equal to, now the other side, that's why we're having x. So it's going to be x to the third plus 1, and then dividing everything by the new power, which is 3 plus 1. Now remember, we want y to be equal to something. So if y is the subject, it means that the arbitrary constant can be placed on the right hand side of the equation. So simplifying this furthermore, we have e to the y being equal to x to the fourth over 4 plus c. Now it would be a bit unprofessional to leave your answer just like that, because you can apply antilogs. Now by introducing an antilog on both ends, so you can antilog it here, antilog. So we can antilog it here. So by introducing an antilog, what are we going to end up having? So we can introduce the antilog here and then substitute with the initial conditions, that is if we want. But if we don't want, we can just first find the value of the arbitrary constant and then antilog, which would be the easiest way. So be mindful, we have been told that y at 1 is basically 0. So what is this telling you? This is telling you that y at 1 is the same as 1 saying f at 1 is equal to 0. So when x is equal to 1, y is 0. Now, let's keep this to mind. What are we having? Let's be mindful. We're having e to the y being equal to x to the fourth over 4 plus c. We know that y at 1 is equal to 0. So when x is 1, y is equal to 0. So let's see what happens. So y is 0, x is 1, then what's the value of c? So I have 1 being equal to 1 over 4 plus c. Taking this other side or transposing it, we have 1 over 1 minus 1 over 4. So we have c being equal to 4. If you do your math right, you have 4 minus 1, giving you 3 over 4. So now we know the value of the arbitrary constant c. This implies that we now have e to the y being equal to x to the 4th over 4 plus 3 over 4. Now we can't leave our answer here. We can now antilog. By antilogging, you introduce the opposite of what you have. Since I'm having e, I will introduce ln. So I'll introduce ln to both ends. Ln of the absolute value. Whenever I introduce ln, make it absolute, of x to the 4th over 4 plus 3 over 4. When it comes to antilogs, the ln and the e cancels out, and since logs allow us to drop the powers, we'll just have y being equal to ln of x to the 4th over 4 plus 3 over 4. So this is our differential equation, which has now been solved. Let's look at this is the last example, and the separation of variables. Say solve the initial value problem. Say we have y prime plus y squared x e to the x being equal to 0. Okay, so y at 0 is 1. Alright, so let's solve this. So we're having y prime plus y squared x e to the power x being equal to 0. So remember, we're having variables of x and variables of y. So it's best that we make sure that we separate the variables. So the best way we can do this is by taking either y prime or y squared x e to the x on the other side of the equation. So by doing that, it implies that this will go the other side, and we'll have y prime being equal to minus y squared x e to the x. Separating the variables, we understand y prime is dy over dx, which is equal to minus y squared x e to the x. So we'll have dy being equivalent to minus y squared x e to the x dx. Now, what we can do now is basically to divide by minus y squared. We have 1 over minus y squared dy being equal to x e to the x dx. This is what we're having. Alright, after having this, what we can do now is to basically introduce the integral sign. But before we do that, be mindful we're having this portion here. I feel like it's best to write it properly, not as a fraction, because the integral of 1 over something isn't always ln absolute of something. It is always equal to ln absolute of something if the something is raised to the power of 1 as a denominator. If it's not raised to the power of 1, then this cannot be applied. Be mindful. Do not be confused. So, this is going to be negative of y to the minus 2 dy being equal to x e to the x dx. By introducing the integral sign of the integral, we can put the negative outside, of y to the minus 2 dy being equal to the integral of xe to the x dx. So with this in mind, what we can do clearly is integrate separately. So I'll just say theta and find the integral of y to the minus 2 dy. This will basically be, remember, you're now not subtracting but you're adding. So minus 2 plus 1, so this will be like y to the minus 1 over negative 1. So now this negative at the bottom will help eliminate the negative that we have in question here. So this means that we're having minus y to the minus 1. Be mindful now, it has a minus outside, being equal to the integral of xe to the x dx. So we're having y to the minus 1 being equal to the integral of xe to the x dx. Now let's focus on this. This is not really the final answer, we're not yet done. So what are we going to do next? Let us understand this and this clearly. We have y to the minus 1 being equal to the integral of xe to the x dx. Let us solve this part as data, this end. Now, the integral of xe to the x dx involves us using what is known as integration by parts. So what we're going to do is to let u be equal to x. If at all you do not know integration by parts, you can always check out the playlist and watch the video on integration by part. Don't worry. So let u be equal to x, differentiate u, you have du over dx, which is equivalent to 1, making du the subject, you just have dx. Now dv is equal to whatever that remains, which is e to the x, integrating dv, integrating e to the x dx, you have v being equal to e to the x. Now using the formula, integral of u dv being equal to uv minus the integral of v du. Therefore, we have the integral of x dv is e to the x dx, du, which is x, then e to the x minus the integral of v, which is e to the x dx. So I have the integral of x e to the x dx being equal to x e to the x minus e to the x, because this part will not change. The integral of e to the x will just be e to the x. Now be mindful that this is the left hand side, sorry, the right hand side, which is being solved. So we expect the arbitrary constant to be there. So we're having y to the minus 1 being equal to x e to the x minus e to the x. So we have our initial condition in question, because this is now plus c. Our initial condition in question says that y at 0 is 1. So when x is equal to 0, y is equal to 1. So we have 1 over y rather is equal to x e to the x minus e to the x plus c. So we have 1 over 1 being equal to, so x is 0, e to the 0 minus e to the 0 plus c. So we have 1 being equal to 0 minus 1 plus c. The 1 can go the other side, and we have c being equal to 1 plus 1. Therefore c is 2. So you have 1 over y being equal to x e to the x minus e to the x plus 2. Now look at this. We're having 1 over y being equal to x e to the x minus e to the x plus 2. Now we want to just have y, so we reciprocate both ends. So we'll have y being equal to x e to the x minus e to the x plus 2 to the minus 1. You can leave your answer here if you want, or you can say therefore y is equal to 1, we reciprocate it, over x e to the x minus e to the x plus 2. So this is how you go about solving such questions. Be mindful that whenever it comes to differential equations, it's quite paramount that one knows how to integrate. Basic integration will be a bonus in understanding this. Alright, thanks for watching. If you have any queries, you can reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and just strategize before becoming a statistic. Let's try to push for that A+.